channel on there that you can post. One of the things that I love about these meetups is you get such a high quality caliber person that comes here, right? You get the people that not only work in programming for their day jobs, and now they're here at a meetup, sharing and spending time with us. That's how much they love engineering. This is like the cream of the crop in this room and online. And so posting jobs in this place is a great place to get access to some of the best talent in Utah. We are also accepting speakers. I think we've lined up for the next 2 months, right, Carson?
Yeah.
Maybe 2 or 3, but we like to have 3 to 4 months out in advance. So if you have a topic that you'd like to talk about, it doesn't have to be about the language of Go. It can just be about anything that's implemented in Go even, or that's like remotely connected, we'll consider it. Because we like to just share interesting things and share information with each other here. So I will turn the time over to Carson. Carson is without a doubt one of the best. I mean, what category of engineer would you put yourself in? I don't want to offend you by saying it wrong.
I've got.
Let's say engineer.
Yeah, engineer.
Sure, we could just say he's one of the best engineers I've ever met. He has the most viewed educational video on CNCF website. It's Carson's. The guy is super talented. He's one of the most knowledgeable Kubernetes people ever, and one of the best hires we ever had at Weave. So he is so awesome.
And the most organized presenter in the history of the world.
Yeah, like if you want to get sample code from his presentation, like I hate to set it up because I don't know if this one's the same as yours.
It's like 99% code.
Okay, sweet. He posts it all online. It's incredible. If I didn't have a non-solicitation, I'd be trying to hire him every day. So without further adu, we'll turn it over to Carson.
Thank you. Awesome. That's so nice.
That's why I got recorded. So like, that counts as solicitation.
See, you just admitted that you didn't though, so that's fine. All right, I want to pull up my talk. So, do this song and dance with, I don't know why it wants to do this, but it really, really wants to warn me that I'm presenting every time I click away. There we go, just to get that thing off there so it's not distracting anybody. Awesome. Thank you so much for coming. So I'm here to talk about Auth with Go. Specifically, I'm going to focus 100% on on Jot. And we're going to go all the way from not knowing what Jot is at all, through issuing Jots, to taking them over the wire, both in HTTP and Grpc. And at the end, I'm going to show you how to do all of that without having to do all of that. The best thing you'll ever do is to write this out of your life. So, my name is Carson Anderson. Like Clint said, you asked me what kind of engineer I want to call myself, and lately I've taken to calling myself the DevXO.
Yeah, buddy.
Yeah. I'm on the developer experience team at Weave, which means we're not necessarily building the product, although we do sometimes come in and help with that. We're building a lot of the tooling and systems and packages and kind of the underlying layers that accelerate our engineers' ability to grow. That's the dev experience team, and so I like to call myself the DevXO, the executive officer. I'm not necessarily the captain. I've got John doing that for me, but he has these big visions, the company has the visions, our developers have visions, and I'm the executive officer making that happen. So that's what I call myself here at Weave. First I want to get into why Jot at all? Like, there's a lot of Auth methods. Jot is a great one, but it is not necessarily for everybody, but there are a lot of really, really practical use cases for it. And obviously it's important enough that I'm going to talk about it today. So I will get into a bunch of code. We're going to kind of start with some very basic stuff, and then the last 90% of this talk is a lot of Go code. But to talk about Jot, one of the things I love about it, and you'll see this in my diagrams as we go, is that it's fully distributed. You don't have a centralized service that every request has to go through in order to check whether it's authenticated. You get to 100% distribute that across your infrastructure. So when you're using Jot, although you usually have some sort of a user's database or some way of checking to see who's who, once you've got these tokens out in the world, you don't have to check in anymore. And this is super powerful, and you'll see how this scales really well. That's basically me saying the same thing as the issuers here are not in the service path. So you'll see this in the diagrams. We have our issuers, but they don't have to be involved in every decision, which is really powerful. Jot's also great because it's really common. Once you know what a Jot is, you will see them everywhere, and you feel a lot more confident using them. we recently found a way to get Jot tokens in GitHub Actions. So you get, in a GitHub action, you get a token for the action, and you can do a little curl to some internal things in GitHub and get a Jot token that you can pass to third parties, which means we could take out every bit of shared secrets and have our actions authenticate into our systems without us having to do anything other than verify tokens. And that was opened up to me by understanding what Jots were and integrating with them across the board, because they were common. They're also, it's really easy. Jots are not complicated. They seem scary. Auth seems scary. I know it does. But it's really, this is not that bad, and you'll see as we get into it. So, bare bones basic. If you don't know what a Jot is, here's what a Jot is. And I'm going to keep saying Jot, not JWT. I don't know what the official one is, but I know which one I say because I can't be bothered to say the 3 letters. All Jots you can identify at a glance because you're going to see that they're this 3-part pattern. There's a header and a dot and a payload and a dot and a signature. The header is a base64 encoded JSON object. Then you do a dot, then you do the payload, which is again a base64 JSON object. And finally you have a dot and a signature. And I'll show you examples of these as we go. But essentially it's just this, it's just a long string of 3 parts. So here's an example, not encoded, but here's an example of what you might put in both a header and a payload section of a Jot. The header is typically automatically created by whatever package you're using. Almost every single language out there, because it's a common standard, has a bunch of existing Jot packages or libraries, whatever you want to call them. Go has many of them. And it will usually do the work to populate the header. This is kind of metadata about what is going to be in the Jot. The next thing is the payload. This is what the whole Jot exists for. Everything else in front of and behind the Jot is to make this payload. There are common fields, and I'll talk about a few of these. There are common fields in the payload that we use to identify whether a token is who it's for, like pass some of this extra data around and do things like check when it's expired or check if it's too early for a certain token, basically to time scope these tokens. And I'll dig a bit more into why we do that later. But there's these kind of common standard fields that are part of the Jot standard, and then you can put also anything. So in this example, I put a roles list, which is just a list of strings that's the roles I want a user to have. You can do all sorts of complicated data structures here. Maps and lists, nested galore. I've also got just a basic user claim. And these are, each of these as we go is going to be called a claim. And you can have kind of standard claims, which are the top ones here, or you can have the custom claims, which are these bottom 2. Either way, it's kind of just, you're filling a map of data, right? And then you're wrapping it in some header information and a signature. So we take those 2 things, base64 encode them. It's the same data right there. I just converted this to base64. And we're going to jam those together and sign that from something so that we can know later if the data coming to us is from someone we trust. So that's it. So how do we sign a token? Now we've got a header and a payload. How do we sign that? So here's some pseudocode. I will show you the Go code. But essentially, very, very simple. We're going to read some sort of private data. This, in this case, is a private key from a public and private key pair. You can also use a bunch of other methods, but in this example, I'm reading a private key. Then I'm going to have a fake get signature function here where I'm going to give it the header, the payload, and the private key, and it's going to return a signature. A few things about the signature that we get back. It is not super reliable. It's not just base64 encoded, as you can see here. There's a lot of these weird characters that are not base64 characters. And it's going to change depending on the signing method. And mostly, you don't have to look at this at all. This is the crypto stuff that you let the libraries do and you don't think about. But you'll be able to recognize it visually in the token later. There are multiple methods that you can do. So when you're going to do the signing, you can do sort of a symmetric shared key system, or you can do asymmetric systems. This is all dependent on the package and the language that you use. I'm going to, in this example, in all of my code, use these ED25519 keys. They're really cool. I'm going to talk about them a bit later because I hadn't really learned about them until this talk, but they're really, really cool. And like I said, the result's going to look a little different depending on what you use to sign. And it's not just base64, but it kind of is okay because mostly I don't have to look at that signature ever. So we take our base64 header, take our base64 payload, we take our signature, we put dots, and we've got this example of a fully qualified token. If you look closely, you'll see the dots in here, and this is how you can really at a glance say, oh, that's a Jot token. There's the 2 dots and the 3 segments. I will say everything so far has only been encoded. It's been base64 encoded, which is just a clear text reformat of the data. Anybody can read anything in a Jot. It's not encrypted. So do not put secrets in Jots unless you're going to use encryption on top of them. Right? This is for identification and verification. It is not to pass secrets around, and that's one of the big things I see is people thinking, oh, the token is secret because it looks kind of encrypted and it's signed, but it's not. It is not encrypted, it's clear text, you can just decode it and look at it anytime. So we got a token, I've just issued one. How do we validate that token? This is the pseudocode for that, and it's really, really similar. We're going to read the public side of our key pair, right, before we took the private side and made the signature. Now we're going to get the public key, we're going to parse our token out into a struct, and we're going to take that token and verify the signature. This is looking at the cryptographic signature of this token. According to that last chunk of data, has the first part been touched? This is how we tell if somebody's tried to take that token, split it apart, give themselves extra permission, and put it back together and send it to us. We're going to check the signature to make sure it really came from someone that we trust to have this authority. Then we're going to look inside the token at those fields. Remember the expires, not before, those 3-letter codes in the payload? Because the signature is going to be valid no matter what. If I trust an issuer, the token you give me, I can trust until the end of time because the signature will never change. We need to look in those fields so that we can time scope our tokens, right? We want to say, okay, not only did you give me this token and I trust that it really is from who you say it is and you are who you say you are, but I also want eventually this token to not be any more good so that I can make you get a new one, expire your session, or just otherwise have, rotating credentials. So I'm going to talk a lot about verification, that's the cryptographic check, and validation, which is looking at the contents to make sure it's in the right scope of time. And you'll see both of these in play in a second. In the pseudocode, I'm splitting these 3 concepts out. In reality, a lot of your libraries will do all of these operations in one function, right? You say parse the token and it does all of those at once. And you'll see that in action in here in a second. So that is all the preamble. That is my very, very quick, and I've got so much code, so I'm going fast. There's my very quick, what is a Jot? What are we trying to do concept? And we're going to build 5 things. We're going to build a command line token issuer, a command line token validator, an Auth API, a front-end HTTP API, and a back-end Grpc API, and show you how to connect all of those up together. As we go through this, I'm going to build just bricks in this foundation of what Jot is. So if at any point you don't kind of understand a basic concept, don't feel afraid to raise your hand and have me go over a little bit more, because I'm going to build on everything that we make from here on out. But hopefully as we go, we'll kind of be able to just abstract the stuff we already understand and build the interesting things one step at a time. So before I get started with any of the code, we got to talk about key pairs. Remember, we got to choose, and I'm going to make a lot of kind of like authoritative decisions in our helper library about what we want to do with our Jots, because there's a lot of choices, and it helps for whatever implementation you're going to do to say, here's what we're going to do for our system. So I'm going to do ED25519 because of 2 things. It's more secure than RSA and DSA keys, and I also just love how small they are. Like if you've ever seen an RSA key, if you printed out your SSH key and it's like 10, 20 lines or longer if you do really big bit sizes, like there is no variable bit length for this ED255, and they're always this small and they're more secure. So I'm using it because there's no downside to not using that, and Go supports it right out of the box. But again, if you use any of the other key types you're used to, all of this signing, like 99% of the code I'm going to show you is the same regardless of what method you choose. First thing we're going to do is generate this key pair, which I've already done in the background. Now let's start building our Go code. I'm going to build a helper package like I talked about called Simple Jot, where I make choices and have opinions about how I'm doing Jots in my tooling. In this, we're going to basically wrap this upstream package called Golang Jot that already exists in the world. It's kind of the main, and I think was the first big Jot package for Go. I'm using it because it's simple and because I've used it a lot. That's why it's in this talk, is because I'm the most familiar with it. I've also looked at and have no problems with this lestratgo/JWX, which has a bunch of sub packages. It covers way more of the Jot concepts. It's more full featured. It has a lot of cool stuff in there. I have nothing against it. I'm just not going to use it here. I will say that it has a parse token function that if you don't explicitly tell it to check the signature and validate the contents, that it doesn't do either by default. So whatever your library or whatever your language, make sure you are testing it with a bad token that's, that is cryptographically broken or expired to make sure that the things you're building actually break when you want them to break, because your library may not do what you think it does. So let's actually start in the Go code. Let's build a Jot Issuer in our helper package. And it's going to be bare bones, very, very simple. We're going to import our Golang Jot package. We're going to make an issuer, and the only thing the issuer needs to have is a private key. I'm abstracting this way. I just need a private key of any type. Then when I build an issuer, I want you to tell me where that key lives in the file system. I'm going to read that, and then I'm going to use our Jot package actually has a helper for give me, build a private key from a PEM, right? So that output that I printed earlier, that PEM formatted key, we can just build a crypto private key from that with the helper package and build an issuer. So this is basically not even Jot centric, right? I just have a little helper library around parsing a file. This is where the Jot stuff comes in. Inside my issuer, I'm making a issue token function. For this, I'm going to say, again, I'm making opinions here. I'm going to say the only thing we're going to put in our token besides the standard claims is our user and some roles. I want to get the time that's now, because I'm going to use this several times and I don't want it to drift. So I'm going to get the time once, and then I'm going to do a whole bunch of stuff here. But essentially what I'm saying is I want to take my Jot package, build a new token with specific claims. This is the method I'm going to use to sign. I need to tell it explicitly up front how I'm going to sign it. And then this is where I build that map of stuff you saw earlier, right? So I've got the audience, the not before, the issue it at, the expire time. My tokens are really short-lived. They're only going to be valid for 1 minute from issue. And I'm going to tell it where it came from. And then I'm going to put in my custom claims. Now, standard and custom claims are sort of just by convention. There's no authoritative list of standardized claims. They're all claims in this map, but I'm kind of separating them out visually here. So we create a token with custom claims. And we're going to take that token and sign it with our key that we've loaded earlier. And then we get this string out and we return it in this method. Notice this issuer doesn't care about how we got to here. We assume that something checkpoints your users before it issues the token. I'm just writing the issuer bare bones right now. So let's use it. This is an entire command line utility to use the issuer we just built. Right? So we import our simple Jot helper that we're going to build and build and build as we go. I'm going to make a new issuer and I'm going to give it the path to my public key, or sorry, my private key. I need a private key to do issuing. Then I take that issuer, call issue token, say I want, in this case, the command line utility is just going to have hard coded, it's going to issue a token for admin with a couple of roles and print that token. So hopefully everybody's following so far. It's pretty basic, or pretty straightforward. So let's run that command, right? We're going to run the issue command and we're going to give it our private key in that ED format. And at the other end of this, we get a Jot token. And you can see one of the dots already. If I scroll further on, you see the other dot and we know for sure this is a Jot token. I'm actually going to grab this and we'll use it in a second. Because now we've issued a token, we need to validate that token at the other end. So let's build a validator in our helper library. Again, we're importing this upstream package. We just want to wrap it and make some decisions. This looks almost identical to the previous issuer, right? The difference is we have a public key in our validator, and we're going to use a slightly different method when we parse. We're going to parse a public key from bytes. Other than that, it's basically identical to, at least the creation of the validator is identical to the issuer. This is where the meat of validation happens. The validator has one main function that it's going to do, and that is get token, right? So we're going to give it that string that we got from somebody, and we want it to, the validator to parse it as a Jot token and tell us if there's a problem with that token. So going into the code, we're going to call jot.parse, which is from our helper library. We're going to give it the token string that we want to parse out. And this is where people's eyes glaze over, is this embedded function that I've got lower down. This is not complicated. I know it looks really confusing, but the entire job of this function that you pass in along with the token string is to say, based on what we know about this token, remember, we can get the header and payload without, it's clear text. We don't have to decrypt it. So we can get the header and payload, look at them and guess, oh, this came from this issuer, therefore I should use this public token. So really the whole job of this function here is to look at what we know about the token and try to figure out if we should even try to decode it and which public key should we use to validate this. This is where you'd handle multiple issuers. If you want one function where you can say, I can take a token from this guy or that guy, and I'll figure out when I look at it, I'll look at the issuer and tell which of the trusted keys that I have I should validate against. For us, we don't need to do any of that. We're going to do some very basic stuff of saying, does the token signing method even look like the type we support? Right? So we're going to do a very basic check, like, was this even signed with the kind of key we know about? If not, we throw it away. Otherwise, we're going to return the one key we trust. So our function is incredibly simple for this validate. So we say parse it, give us a string, pick a public key to validate against, and if we get past this, the token that we got was from someone we trust and has not expired or is not too early or any of those other claims. I happen to know for a fact that this Jot parse does signature verification and content validation in one function. Again, check your documentation, you may need to explicitly ask or call a different function to do both at once. So let's do it. Let's use that that get token function. So we're going to build a new validator. Again, this one needs the public key. And then we're going to call get token, and the second argument to the command line is going to be the token string, right? So this is a very simple command line utility to take a token from somebody and validate it. So I'm going to paste that in right now. And if you remember, my tokens only live for 1 minute, and I've been yakking on for way more than 1 minute. So if I do this, I can prove straight up that it does check indeed. Like, not only did it, okay, it found the token, it was signed by someone I trust, but it is expired. So this token's no longer valid, even though technically I trust who it came from. And that's, again, the big difference between verification of the signature versus validating whether the token's still good or not. So let's see a good one by going back and running the issuer again. So I got a new token that will live for 1 more minute. If I come in here, actually, this, paste that in there, and I run it. There we go. So that time it said, yes, it came from someone I trust, and it is not expired yet. So we got through that get token function, and at the end we were able to print the data out of the inside of that token. And we could do anything we could want with it at that point. It's simply done auth, right? If we don't pass that get token method, then the auth has failed.
Just to make sure, I think most people understand this, but just so you're understood, that you can't, because that stuff is in plain text, doesn't mean you can just go alter it. That's the whole point of the signing.
Correct.
So if you just go in and change the expiration to tomorrow and then try to validate it, it won't validate because then the signature doesn't pass. Because it's like, that's not what I signed. And so that's the reason for the signature. So I know it feels like, why it's public, it seems so easy to edit, but that won't work.
Let's test that. I think that's actually really fun. So if I pull up this, and I just took this first part. It may be a little small. Hold on, give me 1 sec. Yes, you're exactly right. So it's clear text, but again, that's what the signature is for. So if I were my user and I got my token, I said, let me tweak this token. I'm going to decode it. Remember, this is clear text. I can come in here and if I break any piece of this is if I take the header and I change a field, if I take the payload and add a role, it's the same change. Any change between the 2 fields will break this. So I can actually base64 encode this back, come back here, paste that in there, right? And it's, let me get rid of the equals. Yep, so there we go. So that's proving, and if I did the same thing if I took out that payload section and added a role or changed my username, I'd get the same verification error. It doesn't even get to checking the contents yet, because you've now messed with the package. And I can tell that's what the signature is for. So yes, it's clear text, but I can tell when you've messed with it. So that's a good point. So we built this. We've now built the bare minimum of what Jot is for. We've got 2 parties exchanging claims and identity information completely asynchronously from each other. Right? I've got my issuer, it takes in the private key, generates a Jot. Then once I've got that Jot, I can pass it to anybody that trusts my issuer, and they can use that to do authentication. And notice, there's no line. I don't have to have a service. My Jot issue doesn't have to be running for my validate to work. There's no circle here, there's no, like, let me take your token and ask somebody if this is good. I can tell if it's good by just validating it with my public key. So this is my favorite part, and you'll see this again in the later diagrams, but this is all Jot is. All we're going to do from here on out is build on what we just did by adding HTTP and Grpc and just passing it around in fancier ways. This is the new architecture we're going to build. Remember, I said building 5 things. So we're going to build this Auth API that is essentially our issuer in a fancier form. And then we're going to do a curl to get a token from the auth. Then we're going to pass that token to the front end, who's going to be able to verify it with the public key. And then that front end sometimes might pass the token on to the back end, and the back end is going to be able to verify it separately. This is incredibly useful because the front ends now at this point do not have to become the gatekeepers of the back end, right? The front end gets to look at a token, make sure it's good, and decide if they should do something for a given user. And then they need to call the back end. The back end gets the token, gets to do the same check, and decide if it does stuff. So they're completely decoupled, which is what you really want in microservices. You don't want to have the front end be making these gateway decisions. You want to let the back end, all these other services, each make their own decision. And again, there's no line from these bottom 2 services back to the auth. Once the auth token is issued, I don't need the auth API ever again until I need a new token. I'm gonna focus on just handing public keys like as files to my bottom services. The one big catch with Jot, and I've kind of pointed out here, is that you need to get these public keys to all of your services to verify. I'm doing it with just files. There are other standards like the JWT format where you kind of have a URL that you can go fetch and distribute these public keys by having the services start up and get them from a trusted source. There's all sorts of ways that you can distribute that keys. That's the one big catch with Jots, is that you have to distribute the other side of your verification key pair to everything that wants to verify. It's really not that big of a deal. Yeah.
Just one other comment as well. So when you're doing the signature, if you use an asymmetric encryption, then your public keys can be on your microservices. And if your microservice is compromised, then they won't be able to have access to that private key in order to sign, right? So whenever you use a symmetric encryption, that means that every service has to have the private key in order to validate it. So if you use the public key methodology, then you can still protect that private key. So
Yeah.
throw it out there.
No, exactly. And you should, I mean,
Awesome.
yeah, at this point, you should just always use, I don't know why you want symmetric. Like, it's so easy to do the key pairs. Only one person can issue, right? On a symmetric, either can issue, and it's not as useful. Also, the public keys pairs are public. Like, you can go get the GitHub Jot public key pairs just from GitHub anytime. Like, you don't even have to be auth, right? Because you can just put them out in the world. And if you've got, like, HTTPS in front of those, then that's a way that you can kind of allow, that's how we integrate with GitHub's Jot system, was we just go fetch their public keys and we allow HTTPS encryption to do our verification so that we know that we're getting the right keys. Anyway, really cool stuff. Let's build our auth service. This is going to embed, but this is going to have as a member of our auth service struct the issuer, right? Remember how we had the issuer we use in the command line? Our auth service is going to wrap this in HTTP. So we're going to say, I want to build a new auth service, take an issuer, do some error checks, return an auth service. And you could argue you don't need the constructor, but I always choose them. The main thing our auth service is going to need is an HTTP handler. It needs to handle logins, right? So this is a very, very standard Go HTTP function. So the first thing in this handler we're going to do is check basic auth. We're going to get the username and password and whether or not you even set it. If you didn't give us username and password, you're already not authed. Later, I'm doing some incredibly naive username, password checking statically built into my code. I'm just making sure that the user is admin and the password is pass. And if it's not those two things, you're not authorized. This, when I said there's no DB, I really meant there's no central thing that every request has to go through. You can absolutely, and you would, put some sort of a user's database behind this to check to see if the user gave you the right username password combo. You can do any sort of thing you want to gate whether or not you issue the token, right? I'm not covering that here, so I'm doing very naive, just basic auth testing that's statically coded. But once we get past whatever gate we've implemented, this is the same thing from the command line utility. We're just issuing a token with the username and the roles that we want, right? This hasn't changed. It's just got some HTTP wrapper around it. So at the end of the day, we're going to report that token string back if you give me the right credentials. Then all this is putting it all together, right? We make sure you gave us the right kind of args. We're going to build our issuer just like we did in the command line utility. We're going to make an auth service with that issuer. We're going to make an HTTP MUX and register /login to our handle login method, right? So we're just hooking some stuff up now and starting a listener. This is, you've probably seen this 100 times if you've seen it ever. We built this. That's done. This whole auth server part of our Jot infrastructure is completely built and functional. Let's use it. So in here I've got starting my auth API. Again, I'm going to distribute these as files to my services rather than having them fetch it or whatever. I'm going to give them the private key for my auth API, have a second for it to come up, and then log in with admin and pass and get the token. So there it is. We started it, and you can see I absolutely did get a token, and we're going to just keep building on this. And by the end of this, we're going to have a lot longer script in this slide. So that's it. We built an auth server. If we give it the right credentials, we get a token back. So now let's build a front end service and actually start using this. Our front end is incredibly simple. Ignore this back end protobuf stuff for the next few slides. I'm going to come back to it, but I didn't want to omit it in these slides. For our front end, all we care about right now is our front end embeds a validator. Remember, the issuer does the issuing, the validator gets the token and parses it out. So again, very, very basic. We take a validator in our constructor and we return it. I'm going to omit a lot of error checking code to keep things clean, but check your stuff for nils and whatnot. But essentially, we're just building a front end that has a validator built in, and we're going to make a little helper function inside of our front end struct. And the job of this helper function is to take our HTTP header map and find the authorization header if you gave it to us, rip it apart into pieces, make sure it's the right kind of token that we're expecting, take that token section out and pass it to our validator, right? So this whole block up here is just saying, hey, did you give me an auth header? Is it long enough to actually have content in there? Does it actually have the bearer token type? If you didn't give me the token or it's not the right shape or size or whatever, I'm gonna tell you, you didn't give me a good enough header. Otherwise, I've got the string, right? In that header, there's a part of it that is the actual token. I've ripped that out now, and I can just pass that to my validator like I did in the command line. This is not changed, I'm just doing a little bit more with the HTTP headers. And at the end of the day, I return the token. And this is a helper for a reason, because you're gonna see it in a lot of places coming up. So let's write our first handler on side of our front end HTTP server. This is the claims handler, and its whole job is to be authenticated, right? We want it to make sure it has a valid, good token every time. So we're gonna call this helper function we just wrote saying, here's our headers, get the token out of it and tell me if it didn't pass authentication. If it does, I'm gonna take that token and return to the user. I'm gonna write back to this connection the claims in their token, right? That's all I'm doing is I'm saying, you have to auth, and I'm gonna rip your token out and tell you what was in it. It's very, very minimal, but it shows you an auth endpoint. I'm also gonna write a default handler for my server, and notice that I still want to and have to do this helper because I want even my slash endpoint on this web server to be authenticated. Even though I'm not gonna keep this token, I need to call this to do auth. I am gonna take all this away, but I'm showing you how you would do this without all the cool layers we're gonna add later. And then you do this by just calling this method every time and checking the token every time. But at the end of the day, this is just gonna print okay. So let's build it again. Again, got some helpers, we're building that validator just like before. Then we're gonna build our front end, and ignore the back end stuff, but we're gonna build our front end with the validator. We're gonna register the root handler and the claims handler and start up the web server. So let's use it now. So I've got my auth API that's gonna run up and issue tokens with our public key. I've got my front end that's gonna take the private key. We're gonna get a token, print it out, and then I'm gonna test each of these one at a time to make sure that both my root and my claims are checking for my token, whether or not the actual handlers care about the details of the token. So if I run this now, there we go. We got a token, we got an okay from the root handler, and we got our claims printed back at us from the token. Now let's break our auth. Let's take away, let's take away the variable that injects a token, right? So now I'm giving you an auth header, I didn't put a token in there. What I want it to do is error out on both of those. And yep, it turns out both of those are now authenticated endpoints by looking at that header and checking the token and validating that it's all good. Again, if that token was manipulated under the hood or has expired, both of those would reject just like not passing it at all. That hasn't changed, right? We just added layers on the validation we already have. We built this. We have now built our front end service where we can pass the Jot, and notice again, I'm gonna say this a million times, there's no auth service in here. The auth service is done, right? I don't care where you came from, I just care that I got a public key and you're gonna give me tokens signed by who I trust. And so I could do 1 million requests to the front end, and the auth service doesn't have to be scaled to match 1 million requests, which is super useful in large scale, or even in small scale. Just being able to separate those two concerns is fantastic. So that's the front end, that's the auth server. Let's get into our gRPC backend. And I'm gonna do like the world's quickest gRPC introduction, because I wanna cover the cool parts of it here. Hopefully I can do enough that you can kind of grok what's happening, even if you haven't done a lot of gRPC. So, first thing is, we've already seen our curls and our whatnot, we've been talking about HTTP header data, right? Give me the header name and some values. What do we have in gRPC? Because there's long-lived connections from the gRPC client to the gRPC server. It makes one connection, keeps it forever. So there's not really headers in that connection. But what we do have in gRPC is the metadata package, at least in Go. This is the standard. In Go, there's a shipped Google package for gRPC metadata. And you could standardize on a bunch of things. I'm standardizing on this. And essentially this acts like headers, and it happens per individual request in gRPC. And you'll see me plug this in later, but I want to help you understand what's coming. So we have this metadata package, and we're gonna be able to do two things with it. We're gonna set and create a new context by injecting a map of string to string into an existing context, right? So we're gonna say, take a map of data and stick it into a context and return the new one. Or we're gonna say, I want you to get metadata, get this map data out of a context that I'm giving you. So we've got a setter and a getter. And this is what those look like in practice in Go. And you'll see these again later when we put them in our helpers, but for now I'm putting them side by side. Here's an example of where we take, in this case, an HTTP request context, and we're gonna add in a Jot. This is essentially the same thing as a HTTP header, it's just the metadata form of this. So we're gonna say, I wanna make a new context from this one, I wanna build a new map of metadata, and I'm gonna put in a thing called Jot with the raw token. This is important. Just like when you send HTTP, if you don't have any gRPC, right? So you have two services and they talk to each other over HTTP. You want to serialize down to something that we can all agree on, not internal data structures. So the metadata you want to make sure is something that is the standard. In our case, it's that string format, the raw version of this token. So we're going to take a Jot and fill it in. And at the other end of this, we're going to be able to rip the headers back out of the context. We're going to be able to get the Jot header from it and get the first item, and that's our token string, right? So all I've got is two things here, one that is embedding the raw token before it goes over the wire, and the other is ripping it back out, using context as this wrapper, which is a very Go way to do this kind of thing. We're also not gonna write our own gRPC proto. I'm not gonna do that here, I'm just gonna use this existing one that's right there publicly available, that is the Hello World greeter service, right? So this is how you would do gRPC in the world. You would implement a proto, and then you would render out some Go code. And you would import that Go code and just implement all the functions it generates. So I'm not doing that, I'm just gonna use the upstream one so we can focus on the auth parts I care about. But essentially, for us, we're gonna implement a greeter server. And it has to have one method called say hello, takes a hello request and it returns a hello reply, with the request having a name and the reply having a message. These can get way more complicated, but everything I show you is completely agnostic to whatever proto you implement. It's going to be the identical stuff regardless of how complicated or, like I said, it's not even my proto. I'm just implementing somebody else's and I can still do all the things I'm going to show you. Let's build that service now that you maybe hopefully understand a bit about gRPC. So the first thing I'm going to do is import. And this is a public proto. The generated Go code is out there in the world right now, and I can just import this in my Go programs. And I'm going to build a backend service, and as part of the rule of how we do this in Go, whenever we want to implement a service, we need to embed the unimplemented, this is again a generated type, but I need to embed the kind of generated unimplemented type for my service. And you'll do this, with whatever proto you use. Then I'm going to build my backend just like I had. Again, backend is just wrapping the validator. And here's the say hello method. Remember, it had to implement say hello, take a hello request and return a hello reply. That's all it takes to be a hello world greeter service. And it's going to use that method I already showed you. We're going to take this, we're going to basically take the context that's coming in for each individual request. Remember, inside of that context is our metadata map that has the Jot and the raw version of the Jot. And we're going to have a helper function that rips the token out of that. And this is essentially identical to that HTTP get token from header function that we wrote. It's just the gRPC version of that with some different wrappers. We're saying, go dig into the request details, rip the token out and validate it. So this is how we do that same manual authentication. Because once we get past this, we can assume the token is not empty and is valid. So once in our handler, once we've got the token out of the request, we're gonna go dig into the claims and get your roles so that we can return in our reply, hello, whatever your name is in the based on the input on the back end, and you have these roles. And you'll see this as you'll call all the way through, you'll be able to see each step of the way, these things kind of parse the token and validated it as it went each time. So let's build our back-end main. This is pretty much the same thing as the front-end main, right? We're going to give you some usage. We're going to build a validator from the first argument. We're going to make a back-end using that validator. We're going to do some gRPC stuff where we basically make a listener. This is how you do any gRPC service in Go. You just make a listener on a port. We're going to make a new gRPC server. We're going to register that server as a greeter service, right? So from our imported package, we're going to say register a greeter server, this server, using this struct. That's all we're saying is we want a backend, our backend struct to be a greeter server inside of this server. And then we start the listener. So let's use the backend now, and we'll kind of come back, but we've written our backend, we imported somebody else's proto and implemented the method. So now we are a greeter service. Let's implement that and use that in the front end. I said I'd come back to this. And in the front end, we need to make a gRPC client to talk to our backend. And this, again, is a lot, but we'll step through it. We're gonna dial our backend's address. We're gonna tell gRPC to skip HTTPS, because by default, gRPC wants to do everything over TLS, but for this example, I'm gonna skip it. And then once we've got our connection, we're going to create a greeter client off of that connection. All we have to do is, again, from our imported library that I showed you earlier, we imported the upstream code. We're gonna make a greeter client using that connection, and we can pass that client to our front end. Remember, it took a backend client as an argument. So this is a lot of wrapper around just importing a generated library and building a client type off of it. Now let's use it in our front end. So here's that hello handler I kept glossing over that I need to have. You're gonna hit it with HTTP on the front end, and it's gonna talk to the back end over gRPC and send it all the way back to you. So all it's doing here at the top is trying to get a preferred name out of the URL query parameters so it can use it later. Then it's gonna call that function. Remember, right now, all of my endpoints that want auth have to explicitly always call that function to do auth, even if they don't need that token. In our case, we do, but even if you didn't, you need to call that. So we take this token, we do that function I told you I'd come back to. Remember, this is the setter. This is where this is ripped it out of HTTP headers. This is going to take that same data and embed it inside of our context so we can ship it out later. And if we jump forward, here's that same line from before. Remember, here's the current request with all of its timeout data. That's what's in the context typically, is a lot of timeout data and some other information. We're gonna wrap that in some new metadata, and we're gonna call our backend client, tell it to say hello. Here's that new context that has our metadata in it now, and give it the preferred name. And then it will return an error if there was any error from the backend. Otherwise, it's gonna write out the greeting. So real basic stuff. Essentially, we just made a bare bones gRPC client, put it in a handler, and done a lot of work. You'll notice most of this handler is work around getting the token out and putting the token away to send out. And we're gonna abstract all of this at the end. But right now, I'm manually doing every step so you know how to do it. So here is what we've built now. We've now built the last piece of our infrastructure, which is the front end, talking to the back end. And again, notice the back end gets to decide at its own time, no matter who's talking to it. It's looking for a token and checking the validity. So the front end just passes it on and lets the back end make its own decisions, which is how you want to decouple these things. We're just passing jots around and they validate each time. So we're gonna also, as we go, test that this breaks. Because the front end, I literally can't make an HTTP request through the front end that has a bad token to prove to you the gRPC stuff is validating properly. Because if it gets through the front end, it's embedding it right now. I've made this little command line utility where I'm explicitly calling my backend on its own without a token to show you that validation works. So that's what this is. Before I show you how the good token works, I want to show you what happens when I try to call my backend service without giving it the right metadata. So this is that same front end code. Create a connection, make a new greeter client, say hello, but what's not here is me giving it a jot, right? So this should fail because there is no jot if my validation works in my backend. So I'm going to start the backend, and I'm going to call this command line utility that makes a call to it without authentication. There we go. So that proves, again, because I can't do this through the normal methods, this is me artificially creating a situation where somebody's tried to call the backend, maybe from inside your network, got past your front end, trying to call it directly, and it still needs auth there, which is another reason why you don't let your front ends be your gateways. So this is what we built. This is end-to-end. We got our auth API, our front end, and our back end completely constructed. Let's do our full stack demo. We're going to start our auth API, start our front end, start our back end, give them all a little bit more time to come up, and then do what we've been doing before. I'm gonna call login and get a token, bring that token out here, and then call hello. And remember, hello is going to call the front end, which is gonna validate our token, wrap it up, ship it through the client to the back end, who's gonna validate it again, so that all the way through, every single step has been checking to make sure my token is good. So this is all gonna work, but it's doing a lot behind the scenes. So there we go. So I started my front end, or my auth API, my front end, my back end, and then here's that greeting all the way through where it knew that I had a token, that the token is not expired, it's from someone I trust, all of that, and it was able to rip out the data. And this is where you make authoritative decisions. You know, your endpoint might look at a specific token and say, yeah, the token's good, but you don't have this role in your roles list, so I'm gonna say I can't do this for you, right? This is how you could extend all sorts of extra logic by adding extra metadata into these fields. So I gave you an example of how to rip that data out to use it for decisions. So you're going beyond just, you have to have any token, you have to have a token with the right things inside of it for me to do what you want. So I'm gonna take a drink. Is that everybody following so far? We have any questions? Awesome. So this is the current architecture. I've showed you a lot, and I told you already, I hate that we have to do a bunch of this. There's way too much toil, and I don't want to have to do this, and I don't want anybody that's using my libraries to have to do this. I want to implement this auth checking once for my service and have it automatically happen all the time. We're going to do that with 3 pieces of middleware that we write. And I'm going through a lot of this, but really, at the end of the day, if you're going to do this from scratch anywhere, you write the middleware once, the way your company wants to do it, or your organization wants to do it, and then you just tell everybody, use my auth middleware, right? I'm going to show you at the end how little code you need once you've kind of written these middlewares. Nobody has to understand any of this to use it at the end of the day. Like, you can just get a bunch of auth for free, which is really powerful. So these middlewares not only get rid of a bunch of code and eliminate toil, but they make it so that nobody has to think about auth. It just happens. So again, a note about context. Context.context is everywhere in Go. It is how we kind of boil things down to the lowest level of passing things around. We saw it in our HTTP server, we saw it in Grpc, and we're going to use it a bunch more in our middleware because this is kind of the lowest level way to pass data. When you do context, the standard practices is that when you wrap a context and you add a value into it, there's a little helper to say context with value, you never use raw data types because they're packaged. You can have packages stomp on each other if you both use the same key. So we always create a custom type. It can just wrap an upstream type, right? So I'm making a context key that's a string type, and I'm going to make a context key token. And again, I'm just wrapping my string in my own type. That way, only my package, because it's a private type, only my package can add this value or take this value out of the context. This is just standard procedure in Go. We then write a little helper function in our library that lets us set this, and these will become important in the middleware later. But our helper function says, okay, you give me a context and a token, and I'm going to give you back a new context with that token using my private key, right? So I've abstracted away all the context stuff, and I say, you just give me a context, and I'll add a token into it, and I'll give you the new one back. That's all we're doing. I'm also writing a getter, and the getter's job is to take a context that you give me a context you think has a token inside of it. I will try to see if it has that value. I'll make sure that it matches with the kind of thing I expect it to be there. If you have that token in there and it's the right kind of thing, I will return the token back to you. Again, you always want to abstract these away. You should basically never see context.withValue or context.value inside your normal code, right? This should be hidden in your libraries. We're going to use these a bunch. I'm also doing this really fun one, and you'll see why. I've got a must-get version of this. This just calls my token getter from before, but it's going to panic if it's not there. Because there are a few cases coming up where not having auth is basically a really unusual, abnormal, like I'm just going to freak out because you really broke something in the code if you got here and didn't have auth. And so it's okay to panic. Like that's kind of one of my mantras is like panic more. It's okay to have panics in your Go code, like use errors and return them. But at a certain point when something's really, really exceptional, it's okay to panic. So let's build the first bit of middleware. When we're coming in as our client to the front of our HTTP server, we want to check for auth every time, all the time, automatically. And we do that with HTTP server middleware. And I'm going to build this again in our helper library once, and we're going to use it everywhere. We're going to make a middleware type that embeds the validator. I'm doing that in this case just because I think it makes the calls cleaner. And when you build a middleware, it's going to wrap some stuff. You give me the public key path, and it's going to make a validator for you and embed it in my middleware, right? So I've just wrapped that same stuff we saw before in a middleware instead of my front-end service. And what that means is later I'll be able to take out the validator from my front end because the front end doesn't care anymore. You'll see me clean that out later. So I take a middleware that builds a validator, sticks it in itself, and then I'm going to create a very bare bones HTTP middleware function. And bear with me, there's a lot here, but essentially I'm going to implement this handle HTTP function. It's going to take the next handler in the chain, right? Middleware is typically a chain. So it's going to take in the next thing to call if it's good. If it doesn't call that, the next thing doesn't happen, including the very last request in the chain. And then it's going to return a function. So I'm going to return a handler func. This might look familiar. This is that get header or get token from header function. It's that same exact code from the little function we had to call every single time, but I wrote it in the middleware once now. I can get rid of the other helper function. I've deleted it out of my code base at this point. It only needs to happen in my middleware once. Then Same thing before. I'm using get token on my middleware. Remember, this is embedded the validator. So this is calling essentially the get token method on my validator. Saying, here's the token string, give me the token back. So this is the same check as before, just one function once. Then, this is the only new thing. I'm going to take the current context from the request and add a token into it so that later, whoever is processing it can rip it back out. You'll see the other side of this, but basically I'm getting the token and making sure you have it every single time. If you get it and have a valid token, I'm going to put it in the context. I've got this pre-print, and you'll see why in a second, but I've got this in all the middlewares. If you get all the way to the bottom, meaning you gave me a token, it was valid, it hadn't expired, you hadn't messed with it, I'm going to call the next thing in the chain, pass it the writer, and I'm going to call the request with this new context, right? So I'm just saying, let me look at this, check for the header. If it's good, I'm going to add it into the context so other people can get it later, and call the next thing. If, for whatever reason, I don't get to this bottom, auth will fail. And this handles the auth failure by just early exiting before calling the chain deeper down. So, in our front-end code, let's create that middleware and use it now. So we're going to do something basically just like our issuer, right? This is the same syntax as make an issuer, we're just making a middleware. Give it the path to the public key, it's going to make a middleware. And later, I need to use it. I've abstracted a lot of stuff in our front end here. I will show you the full code at the end, but essentially, I'm going to build this business logic mux at the top. This mux is the one I was building before. It's got my 3 handlers registered to it, but I don't want to have that be the thing that serves requests. I want to build a root mux where I can use my middleware, right? There are libraries that make it so you can do like a mux.use and give it a middleware function, but I'm showing you how to do that with pure Go because you don't need those libraries if you don't want them. So in this case, you make one mux that has your business logic, then you make the bottom layer, and it handles every single request, right? It's got a one default handler through your handle HTTP method. Remember, that method takes the next thing in the chain, and in our case, the next thing in the chain is the entire other mux. So I'm going to handle everything through my middleware function. If it gets to the bottom, it's going to pass it off to the other mux to do more logic and splitting up of requests. You could use the same method and probably pass this middleware as is to most of the common, like, fancier Go muxes that are out there. I have no problem with them. I'm just showing you this in pure Go. So that's it. I've made my business logic, registered it, made a middleware. If that passes, it calls the business logic. Now, my front-end client, I can rip out the validator. All my front ends just assume if you get here, you've been validated. I don't need to validate again. I don't even need the validator. Let's use simpler handlers now. Here's my claims handler. This is, remember the whole thing? I had to call and check the token and exit out and give you an auth error and all that other stuff. Even with that helper function that was like 6 lines of code for this handler. Now, I can use this must helper. Remember, this is going to panic. If somehow my front end, if you get to this method and you haven't gone through auth middleware, I'm just going to panic because you've broken the code and that should get caught in your integration tests or whatever you're doing. So I can make really, really simple code by saying, I basically can guarantee there's a token here, so get it out. And then I'm going to print the claims out of it. So this is that whole handler gone from, whatever number of lines it was to just these. Also, here's the rest of that business logic mux. I don't need a separate function for my root handler anymore. My root handler that was just printing okay. Remember I had to do all that junk, throw away the token just to do auth in my handler? I can assume every single one of these is auth. So my root handler can just print okay. I don't even need to do a separate, I can just do it inline here. You could do it separately, but I'm showing you how simple every single thing that you add here. Every time you do another mux.handle func here, it's always off all the time for free because the middleware is guaranteeing it. So we'll come back to this hello handler, but that's it. We've simplified our front-end code significantly. And we never have to remember to do certain things, right? Kind of a code smell for me is, if I have to remember to do anything, I guarantee you I won't. So that's bad. It's a bad form for anything. So we've basically now built our front-end middleware that's always doing auth all the time. Now let's build our gRPC server middleware. So again, we're going from the front end to the server, and then up to the front to the client. So our server is going to be very, very similar. Anything, if you want to implement a gRPC middleware, they call them interceptors, but it's very, very similar. You just have to have any type that has, well, not even a type, you just have to have a function that matches their certain kind of signature, and that is a gRPC middleware. You just have to have a function that looks the right shape. We're going to do that by making a method on our current middleware, right? So we have one middleware type that has the HTTP server already in it, or the HTTP server middleware. We're just going to add another method on that that looks like the right kind of function for gRPC middleware. And that's what this is. This is really long. but not really. So the first thing I will point out is it has this really long, if you look at the top line, it's got this really long method signature. That's just the gRPC server interceptor signature. You don't even have to understand what all of those are, you just have to put them in there. We're really only going to concern ourselves with a couple of those fields. This part, if you look closely, this first part right here, this is just the get token from context thing that we had earlier, right? This is that same thing where take out the context, find the metadata, get the right field, parse it out, and then validate it. So again, we've already written this code, we're just putting it in a different place, and we're putting it in there once. We're embedding, this is the exact same method as the HTTP server. We're just saying, now take the context we have and add a token into it. I'm printing out a line, and you'll see why. And sort of like at the bottom of the HTTP handler, you have to call the next thing in the chain. At the bottom of the server middleware, you got to call the next thing in the chain. You call that by calling this handler function here was passed in up here, right? So very, very similar concept. Give me a bunch of things. I'm going to mess with them if I need to, look at them if I want to, and then if they pass, I'll call the next one. If I don't call the next one, I can return early and cancel the whole chain. So in the back end, we're going to now create and use that middleware. So here's an example of making that middleware. Notice this is the same code as the front end. I've got one middleware struct that can kind of do anything I need to right now, and we're just going to keep building on this. So all your services just really need to know that build a middleware. For gRPC, it's a little cleaner than using a Go HTTP because we build this new server, and then all we have to do in the middle of creating the server is pass as many functional options as we want, right? So we call gRPC unary interceptor, and it as an argument takes any function that implements the right signature. So this is it. This is essentially where we inject the middleware. It's the only thing I've changed from the back-end code that I showed you at the very beginning. Is when we build the server, we say, oh yeah, build it with this interceptor. And then we register it and we move on. So we don't really have to change anything other than that. Just like the front end, the back end can now not care about the validator. I can take the validator out of my back end because that's in the middleware. I don't care anymore. I can assume everything that comes to me. If I add a bunch more handlers on this, they're all authed by default all the time. I don't have to remember to do anything. So here's the final version of the backend handler. Do you remember how long this one was? This got really wonky. Again, I can just say, you have to get a token from this context or panic because I know that my code has to be broken to even get here without a token. Then I can, just like before, I'm ripping out the roles out of that token and I'm using it in my message. So none of this has changed other than the fact that all that garbage at the top is gone and I can just get the token when I need it. If I don't need the token, I'll still be auth. If I choose not to call must get token, I just choose not to use that piece of data from the context, auth still had to happen whether or not I put that helper in there. So now we've built this purple end here where we've got everything coming into the back end on gRPCs doing authentication automatically. Now let's build the final piece, which is our client middleware. This may look very, very similar slide. It's because if you want to be a client middleware, you basically just have to implement a function that looks like the right kind of function, right? Just like with the server, if you have any function that takes the right arguments, returns the right arguments, it's a client interceptor. Because in gRPC, we have this concept of modifying the requests as they go out automatically, which is, you'll see, makes it really, really slick when we do that final handler in the front end. So we're just going to build another method on top of this middleware struct we've been building on top of. So this is an example of the unary client interceptor. It has to be called unary client interceptor. It has to take context and method and request and reply and the connection and the invoker. It's just this long signature you just copy paste from wherever you want to get it from. But as long as you implement this function of this right type, you can pass it in later. And all this is going to do is very, very similar to everything else. In our case, we expect the context coming into our clients to have a token. So we're going to say, well, the front end HTTP server read the token out of the headers and stuck it in the context. As it leaves the front end via the client, it's going to rip it out of the context and stick it in a different kind of header so that it can go on gRPC the right way. So all we're doing here is saying, get the context, or get the token out of the context we have. Then I'm going to build, just like before, this is the same thing I already showed you a million times. We're building that metadata map with our token, setting that in a new context, doing a print, and calling the next thing in the chain. Right, so this is where you can, again, return early. Like, my client in my front end will refuse to even make a call if you haven't given me a token. So you can kind of auth every single step of the way, again, automatically. Once I implement this and use it, it's in all my client calls all of the time. So if I get to the bottom and I give me a token, I'll invoke the next thing with the new context. So in our front end, let's now add a middleware to our backend client, right? So we're making this middleware in our front end. We already need to do that in the front end to use it for the server. But we're gonna also take that middleware and pass, again, a functional option. We are already passing one of these to do insecure connection. But we're gonna say with unary interceptor. I don't love the way these functions are called because I wish it was called client. Like, I have to look it up every time because these are, like, unary interceptor is not called with client unary interceptor, and I don't know why. But essentially, I call with unary interceptor, I give it the client interceptor, and now again, all of my requests that the client makes will get pre-checked before they even leave my service. So you have to have a token to even use my client. Now, here's that hello handler that was the longest handler in my front end, because it not only in the original form, it had to check that the header was coming in, but then it had to wrap it again to send it out, right? I had to do both of those manually. I had to say, give me the header, and then I'm gonna put in the client for the next request. Now, both of those are 100% automatic. So my hello handler is just get your preferred name, use the backend client to do a thing, return it. Like I'm authed before I hit this, and I'm authed on the way out using this. I don't have to think about it ever again. Just make the client the right way once, and make the server the right way once at the start, and it's always auth all the time at every single step of the way. And this all actually isn't even Jot specific. All these auth middlewares, you can kind of stick any auth method you want in those middlewares, right? The details of that changes a little bit, but this, like, knowing these middlewares gives you a world of possibilities to start doing a ton of things automatically. But in this case, we're using it for Jot all the way through. So now, we built our front end client injection. So you get a token, you come into the front end, we check your token, stick it in the context. As you go through the front end, if you need to go to the back end, when you go through our client to hit the back end, we're gonna wrap your token up and send it in Grpc format. And once it gets to the back end, it's gonna, again, rip that token out. So every step of the way, you're getting authed each time. So here's that full stack demo. We start up the Auth API, give it the public key, start up the front end with middleware, give it the, auth with the private, start up the front end with the public, start up the back end with middleware with the public key, give it a second to sleep, get your token, and call hello. This is the same demo I did at the end earlier in the full stack demo, but we know that our code is much, much cleaner and automatic every step of the way. And it's really cool to see those prints come to life right here. So this is what all those prints were for. When I do this demo, hold on. 1 second apparently wasn't enough for the Grpc server to come up. There we go. Had a race, that's fine. So there you go. So you can see I got the token from the front end, and here's where the server got it, validated it. Here's where the client middleware got it out of the context and set it in the thing on the way out. And here's where the server middleware got it and validated it. Right? So you can see those actually happen in order in your prints by putting some prints in your middleware, which I just think is the coolest thing to see each of those. Even though I don't have to think about them, they're all automatic and happening every time. But at the end of the day, I still have this.
Blasting your auth server, right?
What's that?
All without blasting your auth server.
Yes, I did exactly one call to the auth server to get the token, and even though I did 3 verifications, well 2, even though I used the token 3 times, I never had to go to the auth server ever again. Really fun. So this is the final architecture we built. We built our auth API. It needs the private key, and it has exactly one purpose. And then we're able to send the requests all the way through, have them get processed each step of the way for us automatically, and just assume auth in everything we write from here on out. So I'm going to take a second right before I'm done here and actually click out to the code, because I've only been showing you pieces. This is now, assuming you've written the middleware, right? I've shown you how to write the middleware from scratch and build on this validator type and all of that stuff. We import our helper opinionated Jot package. This is all it takes for my auth API, right? So my auth API is basically bare bones. It's a little main, it's a type, and 1 handler. So there's the entire auth API for what I showed you. If I go to the HTTP front end, this is the final version when I'm using the middleware. This is all my front end has to be. Let me in. So my front end, again, I'm pulling in my package that has the middleware type. It creates a middleware. It creates our client connection with our client interceptor, and then builds the backend client off of that. It's the front end, passing on the client that's already got the middleware injected. We register our business logic handlers here. We register our root handler here, where it injects the middleware before it calls the business logic. And we start it. Look at, this is my favorite part. The claims, like the handlers here are nothing, right? I could add another handler and I don't have to think about token injection. I don't have to do anything. I can just assume everything's safe all the way across the board. My handlers get to just have 100% business logic. There is no toil in these handlers left. Like it is just down to exactly what I care about when I write this, and I don't have to deal with any cruft ever again. Same thing with the Grpc service. I'm showing you this because I showed you a lot of snippets, but I'm going to show you the final code makes, this is what your users have to care about. One person once has to write the middleware and understand how it works. Right after that, you just say, look, use my middleware. Here's the snippet to use my middleware. You get Auth all the time. No one else has to even understand how it works other than that you have to get a key and you need to call the middleware. So in my backend, I'm making the backend service. It doesn't even need anything now because again, it doesn't care about the validator. I create my middleware like I was. I pass the option to inject my middleware at the server end. Start the server up. Here's my backend. My backend handler again doesn't even have to care about Auth. It can get the token if it wants to, but it becomes pure business logic. It only gets the token here because it cares about it, right? Oh. That just. All right, I think it just died. That's okay. We're basically done. So I don't know why it restarted. Maybe, oh, shoot.
The remote people all got dropped too?
No, the remote people are separate from me. So my screen froze, but that's it. I'm gonna get it back online so I can pull up. I was just gonna show you, and you can look at the code. That was basically, I had one piece of code to show you, and that was the final middleware. The only other thing I want to say is, yeah, I'll put a link at the end. It's all of that I gave you, it's all open source. It's in the repo with the whole presentation, every bit of that code. If you want to go rip it or steal it or reference it, like it's all out there under my GitHub and publicly available as of today. So that's it. I'll start this up so I can post that link. But that's it. That's Jot and Go.
All right.
Anybody have any questions? Yeah.
Just one other comment. So this was a while ago. I was auditing a Jot service for a bank. And the way the validation worked, the order of operation was incorrect. So then you can kind of manipulate how the Jots work. So
Yes.
just kind of one thing to remember is order of operations when it comes to Jot is very important, right? You got to validate the signature, make sure it's not expired, read the claims. If you don't do it in that order, you'll end up with security holes. So
That's a good point. Yeah, I can see how you could manipulate the issuer and say, yes, I issued this, and yeah, perfect.
So,
Sorry, then Jason.
so what happens if the private key is compromised and the JWTs are out there?
So, if the private key is compromised, that means whoever's got your private key is now able to issue Jots on your behalf. So the Jots that are out there are still valid, but the risk is that somebody could then say, I got the private key, so I'm gonna make a Jot that gives me super admin and pass it to some service, and it's gonna be considered good.
So if the server realizes that like, okay, my private key is compromised and now they're rotating,
Yeah,
what
so,
happens?
There's no revocation. You can't revoke a job.
correct. This is why you see, that's the one big drawback, right? And this is the pro Jot talk, so I'm talking a lot about, but the big drawback is signing out or revocation. Typically signing out with Jots means deleting the token from somebody's local storage in their browser, which isn't, they'd save the token, they still have it, right? But to them, it's signed out. And again, invalidation of those keys, you really, it's out there. It continues to be valid for as long as it is. That's why there are, and I didn't cover them because they're add layers of complexity. You could do everything I've done by add that on top, but typically what you see rotation. So the JWT standard that I referenced just for a second, that second Jot package in Go actually supports it pretty well natively, including like caching and some other cool things. But the JWT standard says, you can go to this endpoint, we're gonna give you a document in this format that tells you all of the keys that I might have, so I can have multiple public keys that are valid at once, so that I can have two and then eventually only issue from the new one, so that eventually the old one. So that's solved a lot in Jot by just constantly rotating the key pairs that you're using.
Also, they're rotating the private key.
You rotate the private and you have to rotate both, right? So.
I think Google does it every 24 hours.
And it's not that bad. If you use the JWT standard, that Lestrat Go package does just, you can kind of say like, here's the issuer I want to trust. And you have to have some usually upstream HTTPS connection where you go get those. But it knows how to like get those and periodically refresh them. And when you've got a token coming in, figure out which of the 2 public keys to test against. And there's some wrapper stuff that you don't have to write yourself that lets you handle rotation.
And then usually there's 2 tokens. You have an access token and a refresh token. One's long-lived, one's shorter. So then if there is a compromise, it's only compromised for 5 minutes instead of days.
Awesome. Yep, go ahead.
Do you want to talk about the encryption algorithm none?
Yeah, no. Well, you mean the signing algorithm?
Yeah,
none?
signing algorithm
Yeah.
none.
You can choose to use Jots for whatever reason by signing it with the none method, right? Remember I chose, I would say there's HMAC for symmetric, there's RSA, DSA, ED keys. You can choose to just have Jots as a really unnecessarily complicated data interchange format, I guess, right? Like, just send maps of data if you're not gonna sign it. But that is, yes, it's technically, according to the spec, optional to sign.
What does the signature look like? Is it just?
I don't know,
It's just empty, there's nothing.
This is a dot.
So
It was the default for the Go package for a long time.
Oh, really?
a lot of old packages would accept the none, and then it just wouldn't check signatures for you. It was,
Like if the client sent none, it would just be like, okay, cool.
Geez, that's horrible. All right, I'm gonna join in so I can link that last bit with the code. Any more questions while I'm pulling that up?
Clint told me that once everything's on the blockchain, that this is obsolete.
No comment.
Need Auth.
Oh, man.
Public private key now.
Let's go, run. You can actually run this whole thing, including all those live examples, if you pull down the repo. Maybe you can't see that. If you pull down my Let's Auth with Go awk repo, you can do the run on it. Something really bad really happens. I don't know what happened there in my Go installation. Anyway, you pull it down, you do the run on that, you can actually step through that Go present talk yourself and run with your local examples and all of that. Obviously, my thing complete just crash out and mess something up. But I guess for the last thing, I will pull up the talk.
The GitHub link's on Forge Slack already.
Oh, is it?
I just posted it, so
So fast. Anyway,
you should just join the Forge Slack and then you have the link.
perfect. Yep, and so there's instructions on how to generate your key pair, how to go ahead and start this, do all, like play with the tools that I built or look at all of the code. So if you're curious about the last thing I didn't get to show, which was the final version of, I made a bunch of files here, but my whole middleware is maybe 100 lines of code, right? And it's mostly just boilerplate code. So it's not complicated and it's all open source in MIT, so steal it, so. Cool, if you wanna, yeah.
can I make an NFT of your code?
Yep, just for you.
Never ending forward.
So question on, right, if you have kind of, nested where your, backend passes down to, 3 or 4 sub-services, do you typically pass the same, like, that user jot all the way through? Or, like, I'm thinking like if I want to restrict the services that each service can talk to, or do you pass the same one through and that first one person has to be auth for everything? Or do you replace it at each stage?
Yeah.
Is that clear enough?
Server to server token.
Yeah.
I would separate both. There's nothing in what I did that wouldn't, like, authorization is a header, convention, right? So if I was doing it, I'd say authorization is for my user tokens and server authorization, including in the Grpc, like that whole metadata map, I would build a Jot and a server Jot. And those are 2 identities, right? And I can validate in any order. I can say, well, I expect you to give me a server Jot that I trust, and I can look at this, what that server can do. And then also I get to decide, the user Jots. That's where I would go with it. I would not try to
Have
mix
a
and match.
user be a claim of a server job.
Is that true?
Once again, it's just reinventing things that have been done in XML for a long time. This is SAML, this is XAML, this is like, it's usually,
Jason, so it looks cooler.
yeah, usually you can start nesting stuff as claims. You could abstract it, like if you just cared about, well, my front end's gonna do everything, and my front end will take the user and know it came from a server, and you could have some prefix on claims, meaning that it came, like, you could flatten the tokens, but it's just easy to just start nesting stuff.
That makes sense. So you know who initiated it, but then you can still assert server level
Or
stuff.
just keep them separate, like, I mean,
Yeah.
you can add as many things to the metadata as you want.
That ED token, like, is really, really efficient and fast, so I don't think it hurts your servers at all to do two separate.
The problem gets when it's like long lived, like if you have an hour-long operation, and then one of your keys expires partway through it, you're gonna be like, how did I get here and I failed on my token? And it's like, well, because everything's point in time when you check it, and that's why some people will unroll it and flatten a token, so that it's a point in time, yes, when this was issued, this is the valid claims. Otherwise, you have to, like, time starts messing.
Have you ever had to deal with, if you have to put, if you're never checking an auth server, and let's say you have like a really complex permission structure, like not just a role, but maybe you're putting like all your ACLs and they're highly customizable across all your users, that token could get really big, right? To the point where it's like, oh crap, like I'm sending this on every request.
Yeah,
on my
no,
mobile phone or whatever, you know, like how have you seen and dealt with maybe that's outside of the scope, but have you seen strategies for dealing with really large JWT tokens?
I don't have anything offhand that I can say, 'cause that is a problem for sure.
HTTP2 always just fixes the problem.
Blockchain,
The blockchain.
The blockchain, yeah, that's,
No, HTTP2 doesn't send.
but only if you use Solana.
Put it on the ledger, and it will be good.
yeah, I don't, that's a really good point. I don't know, at that point, it's a lot trickier, because you aren't supposed to put in your Jots like tons and tons of data, right? There is essentially a limit to,
I
a
mean,
functional limit.
There's
to-
separate systems, right? So usually you have identity systems and you have access control systems. If you really are getting all your information from one of them,
At small scale, it's fine to have that all the job, right? But, yeah, you're right. I think
just think of, so Kubernetes does ACLs inside and they use Jots everywhere too, so.
I was gonna say for like Google Cloud stuff, right, I think they've got the magical whatever metadata server that I wish for workload identity in GKE that I think just,
It takes a
Yep,
Jot and
it
turns it
takes-
into an OCID, that's what its entire job is.
and I think it only restricts, like it says, oh, I've authenticated you for the thing that you asked to do.
Yeah.
And so it only embeds your role for
Yeah.
For that specific.
specific.
And that's the right way to usually think about it. So instead of having one end-to-end, once you get an identity of a user and you're like, okay, I know you are this, you should be using different Jots like everywhere throughout your chain. Because you don't really want to go all the way through to the user, because then you do have to package everything up. Like, okay, well, this system can talk to these services and then pass a claimed identity through. Not assume the claimed identity is where you want to embed your access control, because
So then it's not necessarily like, you will be pinging some sort of metadata or auth.
but it's
service
usually
every
on the
time.
system. So if you're inside Kubernetes,
Yeah.
a service account, that's a job.
You're checking it
If
in.
you're on a VM in any cloud, a metadata server, it's a job. Like,
Yeah.
every single point in the chain, because the only person that can verify you're on that VM is the cloud provider. The only person that can verify you're inside a Kubernetes cluster running in this pod on this name service is the kubelet.
Yeah.
And so that's where each piece of information comes from the canonical source of it. And you just pass things down. You don't try to like bundle everything up. You're more just like, oh, well, I need to make an open auth OID call. So I'll talk to the metadata instance to exchange my Jot for an open ID. And then that's the thing that actually leaves that has all of your information.
Okay.
So it's kind of more point to point to point to point.
But so it is making a request, but that's why they're embedding it on your VM, so it's a local.
Yeah,
Call.
so,
You
okay.
can still crush it. Don't send too many to that metadata server.
Yeah, and I was admittedly,
Not to kill your auth server, but I get what you're saying. If each service controls its roles and privileges that it's checking, then it will only check when it gets hit. And all of them, it will be a little bit more distributed.
And you could cache it because, you know, if you're inside a pod in a context there, you half the information in there doesn't change, and so you could then take that and embed it and only have to,
that's
like a composite style thing. I think you can get signing tokens out of a lot of these too.
Might be
So
able
like
to,
you
yeah.
can start being your own issuer that composes other claims that were passed to you by Jots.
Is that metadata server open source, do you know?
Doubt it. The stuff inside Kubernetes is, so you could steal all of that.
Most of these in the cloud are like context dependent as well, so it's not like you're saying, like, oh, you're gonna hit your auth server, it's 1,000 different auth contexts, like IAM is made up of so many. IAM in both GCP and in AWS is so many different mini services that you're not hitting one, you're hitting 12 in the process of a request.
Yeah, no, my whole thing is like, I am mixing authorization and authentication, right? Like, Jots are technically for authentication, they're proving you are who you are. I mixed in some role stuff, because at a really small scale, it's fine. But, yeah, exactly, I think at any other scale, you would, again, you wouldn't go to one service, but you would delegate pieces of it out. Cool.
Or you can go full ADAC and really complicate your life.
You could, if you hate yourself. Cool, we can keep going, so I just wanted to close up for the recording and everything. So does anybody have any other questions, and we can go back to shop talk? Cool, awesome. Well, again, there's the link. Feel free to go out there and steal it and use it, and hopefully it was helpful. We'll stop the recording now, and we can talk for real.